Thank you. Thank you, Phil. With that long of an introduction, now we have about 2 minutes left for the actual talk.
Well, you're just so accomplished.
I'm just kidding. All right. So what we're going to be talking about here is clearly around what is happening within the OFA's Open Fabrics Management Framework work group. And so just a little background on that. The what's driving the work here? There's multiple things happening in the industry that are key drivers for why this group was formed and for the work that we're doing. Everything from cloud designs and high performance compute becoming more heterogeneous. And so it becomes more and more difficult for folks to use single point fabric management tools because they have to go from fabric to fabric to fabric with completely divergent sets of tools and trying to do more and more functionality within those environments. In addition, there's a whole raft of new alternative network fabrics, new way to deploy memory and custom accelerators that are coming into the market and also playing in a fabric interconnect space. So we have CXL and Gen Z have both been in the space of presenting fabric attach at different points in the system. So we get to kind of this third one here, which is this different fabric technologies is proliferating. So I've already described a little bit of this, but if you look throughout an entire ecosystem, you have fabrics for network, for storage, for accelerators, for memory, and that trying to manage each of those with different sets of tools requires a lot of overhead. So that's one of the things we're starting to look at here is this really gives you a management headache. So because they're today across all of those plus more, we haven't even talked about InfiniBand and some of the other interconnect options here, but there is no common fabric manager interface or fabric model that links these things together today. There's standards-based infrastructure that would enable that, and we'll talk about that in a little bit. The workload management and optimization, this is a big one. This is different for each type of fabric. So learning the intricacies of not only configuring, but optimizing those environments is a tremendous challenge. And administrators are being asked to manage, more and more and more of these in their same environment. And each one has its own management standard and management model. Some have just relatively proprietary tool sets. Some have standards-based tool sets. So this is kind of, so what are the things we're looking at here? And so this brings us to, the solution we're working on to help address that in a standards-based way. And that is, again, the Open Fabric Management Framework. And the work group and the product are named the same. And OFMF is one that took me a long time to be able to say without as a tongue twister. But what we're really looking at here is, fixing that and standardizing that interface across not just the upper layers, but the lower layers as well. So providing that common framework in there, an open source reference implementation, as well as an architecture for a way to cover that management functionality across the board, everything from configuration to workload management, which may be memory-based, maybe storage-based, basically just building that ecosystem up more and more. So it starts with some basic things like control services of, just basic discovery and inventory, managing connections from within the fabric, as well as from client and application initiated requests. And then traditional things we've seen in large scale fabrics that are now scaling to these other types of fabrics is so zoning and connections and managing permissions throughout the ecosystem. There's a broad range of that. I've really described a lot of the basics here, and then we go to build on top of that. So we look at managing the workload and the instrumentation and all of those that come in kind of our second phase once we have this base architecture defined. Okay, so how are we doing this? First thing we're doing is we're really working on leveraging the expertise and leveraging existing standards work to do this. Building it all from scratch would be a tremendous amount of work. So instead, what we're trying to do is work in the intersection of other organizations and allowing people to bring their own expertise. So DMTF has that server and basic fabric management standard. And so that's a core of we're working on. And then as we get into that workload management, workload optimization, we bring in folks like SNIA and Swordfish, which SNIA or the SNIA Swordfish is the storage extensions to Redfish. So it's a very seamless solution there. Then we bring in the folks on the Fabric side. So what we're going to be talking about today, we have a demo coming up in about 40 minutes, something like that, 45 minutes. We'll be showing how we're starting to, make this thing a reality based on some of these new fabrics, based on Gen Z, based on CXL. How are we bringing that together? And then the fourth bubble coming in is, of course, the Open Fabrics Alliance, bringing in that both the user and system side expertise for fabric management. So what does the open framework look like? This is normally a build slide, but okay. So apparently copying it over didn't keep that. So if we just kind of look down at the top, we have a whole lot of different clients and applications that we want to enable. Everything from and here's some of the just kind of some of the functions, right? Attaching shared memory and managing memory. Regions from the library level or up to application levels that are looking at, managing the networks itself, or just base configuration like creating zones. There's a lot of different use cases here that these client layers are trying to do across the board. So that brings us to our OFMF, domain and the basic architecture here. First and foremost, this is based on a Redfish and Swordfish model. As we noted, those are existing standards where Redfish covers the server and fabrics and Swordfish brings in the storage expertise. That those management standards provide the core of how we reflect the functionality of the OFMF up to all of the clients. So you end up with a lot of work here that we can leverage directly, and then we can focus in the OFMF off on what specific functionality we need. Is there stuff that's missing in those standards, particularly as we're adding additional fabric types in, and then what is the overall architecture and how do we create the framework to support? So our basic model is, Redfish, this entire layer is Redfish and Swordfish compliant. As we move down the stack and the information we feed into that, we have underlying agents for each technology, and you can see these color coding a little bit. The main thing these agents do is translate from whatever their native model is, whether that's a standard or whether that's proprietary instrumentation, but translating that to speak Redfish coming out of the top. So these agents they're kind of inverted here, but the agents actually all talk Redfish up. Now these are not full required to be full Redfish implementations, just for the portion of the functionality we're looking at here. Okay, so what does that look like? If we start looking at, kind of presenting everything in a Redfish and Swordfish way, we end up at this upper level with a bunch of services, managing sessions, managing event notification, logging. The telemetry service is for metric reporting. A manager function that just helps manage the ecosystem depending on how it's instrumented. So all of those kinds of things can just sit off to the side, and it's not a focus of any new functionality per se for the OFMF at this point. What we're really looking at doing is getting into this fabric model. and saying, all right, so this is how fabrics are set up. You may have systems or storage over here and systems that you want to connect down to become consumers of the ecosystem. And then you have the hardware representation, which is what the chassis covers. And then over in the fabrics model, we get into both that connectivity mapping as well as access right management. So that connectivity management is our classic. Here's a switch. Here I'm going to create some zones, and that basic functionality, and that's what you see represented here. So for the specifics of a particular technology, say we're talking about Gen Z or CXL that are memory-based fabrics, then you see the physical modeling of those over here under the memory domain. For working with other types of fabrics, the modeling would look a little different. This representation is really just talking about what you'd see in our POC work today and kind of our starting points. But most everything else should be identical as we move forward. And then up here, we have little composers or clients that are able then to talk down through the Redfish service route and access and see any of these models done consistently. All right, so there we go. That's a really quick overview of kind of some of the things we're working on. And so we're doing a lot of POC, proof of concept based work, which we'll demo in, I guess 45 minutes. And that is available for anyone if you want to go look and see what we're doing, if you'd like to join the work as well. But if you just want to get started and look at that framework and agent layer and figure out how they work together, you can go get our POC code. We actually have 2 different versions of it. One that actually expects live hardware, and one that can run basically to a fully emulated agent. We also are working to make some of these things available in containers. So we have the OFMF and the agent POC containers available for download on repository. These are available on my repo right now. We're working on getting things set up so that I can post them to the OFMF or the Open Fabric repository shortly. But these containers are out there. So if you just want the 2.5-minute install, and then you could focus on how to on actually working with the system rather than the process of putting them all together. You can actually get started with the containers. So we have a lot of different companies involved in this project. I've talked about some of the key alliance organizations, CXL, Gen Z, SNIA, DMTF, that are involved, but we have a lot of other companies that are also involved in helping to drive this work forward. And so you can see the broad range here. If you'd like to get involved, again, the project info is on the openfabrics.org website here you just go find the link at the top under projects that says the management framework. You're also welcome to just join the mailing list, which I have the link here, but it's available on the website, or join our weekly meetings. We'd love to have more folks getting engaged. All right, so Phil, what questions do we have?
Well, we currently have a couple of questions queued up. The first one, how are different OFMF clients isolated when OFMF allocates physical resources to them? And basically, they want you to shed light on the permissions model used by the Open Fabrics management framework.
Okay, so there's 2 layers to that. This really easy one, the integration between client and the framework itself, is handled by the Redfish definitions. And this is a session-based system. So each session is distinct and unique between clients. and is managed with secure access as well. There's multiple options for how to do that, but it's all well defined within the Redfish ecosystem. Everything from username, password to certificates to however complex you actually want that to get. So that's the first layer. The next layer is about that is what are we doing to manage allocation and resources within the OFMF. And basically it's similar to any other management ecosystem that's managing a fabric. If we have client A come in and configure portions of the fabric, then that change will be propagated out and visible to other clients. We have not at this point put in any OFA specific or OFMF specific access rights and restrictions, but that's also a layer we can do is as part of that configuration of your client server, you can decide what portions of the system any particular client is allowed to configure or even view. So there's kind of all of those different layers, but basically once somebody puts a request in, assuming they have the authentication rights to put that in, then that change will be propagated out and visible to other clients based on their permissions.
Okay. There was a similar question about security controls. What can you put on the fabrics?
Security controls on the fabrics. So I talked, what I've been talking about so far has all been kind of at that upper layer and the integration between the client and the framework. If you're talking about what we're doing down, there's a couple of layers as well. One of which is when those agents are developed, they'll actually control a fair amount of that. Part of the security model we have is an authentication scheme that we're developing that will work between those two Redfish layers. And that will provide a piece of that. As a part of the overall framework, if you're talking framework down to agent, the framework will have to authenticate to the agent. And it depends on how that agent, how open that agent is and what it's exposing on how what the security model will look like a bit there. If there are restrictions that the agents that we want to build into an agent for a particular technology, that's still a future topic for us to work through.
Okay, cool. And hence asking for more people to join and help us out with that sort of thing. Okay, cool. Let's see, another question. Actually, this question I actually have gotten a couple of times on this topic, and it's really good to raise, which is how does the Open Fabrics Management Framework project itself, but how does the OFMF compare to similar efforts being done by, say, Liquid on a multi-fabric composability?
It's a good question. If you're just looking at the high-level description, it's like these things look the same. So you get to there's first and foremost, this is an open source reference implementation target. That's what we're heading towards. That is entirely standards based, and you could plug any fabric underneath. So while we're looking at what are the use cases we're trying to ensure, we have to make sure in the OFMF that they work consistently across all fabrics. You get something like Liquid, they have their own hardware component into that, and they could strain a little bit. So they're basically trying to solve the same problem, but on a smaller scale. So what I would expect if you're comparing where the OFMF is at any given point with a point product like the solution Liquid's doing, Liquid's going to have potentially a little bit more functionality, and that's the kind of thing we would try and bring in and say, okay, these are the important use cases for us to address and work on how to build those out. Remember that we're trying to also build things that work across all those different fabric types at all layers of the system. So abstracting those into a common model is a bit of a challenge. So that's where we're spending a lot of our time, and as opposed to a much more constrained environment.
And a really good follow-up question: could Liquid be a client of the OFMF?
Yeah, absolutely. They could plug in on either side. Honestly, if they want to plug in as a client and take advantage of the abstractions we're providing across other fabric types, absolutely. If they want to partner that with their, their own infrastructure that they're delivering, as in presenting basically one of those agents, think of it as, or a group of agents underneath there proxying for the network behind it. We could also plug them back in on the back end.
Okay. And if you could slip to the spaghetti slide for a moment, there's a question on that.
Sorry, let's remember which slide. Slide 5.
I want to say it's 2 or 3, perhaps.
Hang on.
Sure. I mean, the question, it doesn't necessarily require the slide, but what kind of clients can take advantage of the OFMF redfish swordfish framework? There's a question on the slide too, but
honestly, this is one that's talking more specifically about fabric management, but any enterprise management client can also take advantage. We have a REST-based interface on top. So if anyone wants to expand this list of clients, you could do that. You could take it and extend your server storage and fabric management that are redfish based to include a representation and talk to the OFMF. So that could be a vendor value add that actually just talks redfish down the bot, to the fabric management and to the devices, and reflects that up. So everything from configuration management to detailed fabric management configuration.
Okay. And there's a question I'm going to ask you, and I'm also going to re-ask it during the demo session in an hour or so, about the core components of a fabric agent itself.
Okay. So the core component, the fabric agent over here, you can see we have 4 of these. Again, think of it as a mini redfish that the bottom half talks through to the product. So it's really up to the architecture of, I'll just focus on this top one here. So it's up to the architecture of what you want to put in the agent versus what is in the underlying software. But basically the agent's constructed with a redfish interface on top and a proprietary interface on the bottom. It will have security mechanisms so that we can, it's not, if it has not been designed as a complete redfish implementation for folks to access directly, we'll have kind of a restricted set of security and discovery so that the framework can discover all those agents. And then again, it's a little bit up to the agent and underlying combo how much statefulness they want to contain. So an example of that is, the framework will actually keep an updated reference of the state, and then use the event interface in redfish for this agent to notify the framework of any changes. So that event interface basically abstracts whether the information needs to be saved within the agent or whether it's just doing a pass through to the underlying system. As long as it's performant, it doesn't really matter. The other piece is the agents need to they don't need to communicate between multiple instances of the agent, but they do need to report things back in a way that we can identify and consolidate and make the complete picture from the upper level framework. So say you have a fiber channel agent and you decide to embed that in a fiber channel switch, that would mean every single switch is going to be presenting a view up, and it needs to just basically have the basic understanding that this is my view of the world, and that may not be the comprehensive view of the world. So it's basically you establish the domain for the agent and ensure that the support of multiple simultaneous agents of the same type are able to be consolidated up in the framework.
Okay, very good. Thank you. As I said, I might ask that question again at during the demo section, just to hear that answer as well. Okay, that is all the questions I currently have. Does anyone else have any questions? I really enjoy this sort of discussion after a talk. Okay, are there any final words, Rochelle, before we turn it over to our next speaker, which is coincidentally you?
let's see. I don't think so. Just again, I will go back to our, our links. Feel free to go in and check out, and especially after you see the POC demo in a little bit, you'll want to go and, remember that our GitHub site here is referenced from the openfabrics.org page as well. But you can go get all of these different components and just start working with them. And again, we'd love to have you join our work.
Yeah, we were very open and inviting group, and anyone who has a interest from a client, application point of view to a fabric point of view to whatever, it's really good to get more voices involved. All right, thank you very much, Rochelle. Very, very good talk. Now we have your next